Next, I want to do a walkthrough through 7.1c, which is the file where the scientists are shooting. 7.1c, by the way, and 7.1g, if you look at the files, they are using the same footage. It's one shot, but 7.1c is where all the action is happening. So it's the shot where the scientists are shooting, and well, there is quite a bit going on. For example, there's a camera track and 4 object tracks in one file. There is particles, there are, how many is it? 6 or 5 robots. So lots of stuff happening there. So let's first have a look at the track very briefly. So 7.1c track, I have to change the path to linear HD. So go here, P linear HD, accept. All right, so that is the footage. So first you see there is a camera track, but then there are also 4 object tracks. So there's object track for Campbell, who is playing one of the scientists. So that is this. Maybe I can display the path at least. Okay, so that is this. Then there is an object track for Kuhn, for Kier, and for Dan. The problem with this file is that it was, I think maybe it was the first track that I did in this movie, or one of the first. So it was done with the old tracking algorithm, so when we still had hybrid KLT and SAD, and at some point that was changed to the new tracking algorithm, and during that change apparently also the way that pattern and search area I displayed changed something here, so you cannot, even if I activate these buttons, pattern and search wouldn't show up. But at least you can see the tracking points and the path. And well, as you can imagine, tracking these was a little bit of a challenge. So that took me, I don't know, maybe a week or something until I had all of these arm guns tracked. Because, well, there was the nasty flipping problem. So I had to try to get the right keyframes. Unfortunately, keyframes, you know, the keyframes that are used for solving, these ones up here, are not being saved per object. So when you track the camera and set keyframes, for example, to, I don't know, here and there to solve that, and then you switch to one object and set keyframes here and there, then that is changing globally. So you wouldn't be able to resolve that because I didn't write down the keyframes, and the keyframes are not changed. So, well, that's not possible. But at least all these objects have different colors for the tracks. So this is green, then I think Campbell is yellow or something. So if you look in the 3D viewport, you can at least tell what is what. So these are the tracks, and you can see from this perspective it looks quite bad. So there's a lot of jumping and it's very uneven, but the overall movement is correct, more or less. And if you look from the camera view, then you wouldn't see the jumping, because from here everything looks fine. There is one problem that you will find in a lot of files, and that is that I don't know why that is happening. I think at one point it was fixed, but then something happened and it went back, or I don't know. The problem is that in the camera settings, this is not the correct focal length anymore. The correct focal length is what is being used on the solved camera object that you can see here. So that was a wide angle lens, 18 millimeters. But when switching from the linear HD to the 4K, for some reason it changes the focal length while I think I don't even have to resolve. I think at one point it just changes. There's probably some operator updating problem happening, I don't know. So it can happen that in some of the files that you will see that the tracked camera doesn't have the correct focal length, at least not in the movie clip. But that is really not a problem for the file, as long as the actual camera in the 3D viewport is using the correct focal length. But be aware that if you want to try to resolve some of these, that you should have a look at the focal length and check if it's still correct. So if it's not correct, then you can just copy that, Control C and then Control V, and that would then work. So this is the object track. And the other challenge was masking. So if I look at the mask file, that will be quite a complicated setup, but also it will be broken. And the reason for that is that we have been using the old footage, or not the old ones, but it took a while until we had the Open Color IO conversion thing going. So to get things moving, we had to use the old ACES footage. Now ACES is a certain color space that doesn't really match the color space that Blender is using internally. So we had to kind of work with the wrong footage, and also Roman had to do all the masking and keying with that old footage. Now, if I go to mask mode, first of all, you can see there's lots of masks, so that was really insane. He was even masking out the cables over here, so that was really a lot of work. But let's have a look at the node editor. So here you can see that there are two separate node trees. So this was the node tree that Roman used for keying. And if you compare that kind of green to this, you can see there's quite a difference. So all the footage was looking like that. So the green was totally wrong, and he was keying with that green. And that means that if you would now switch back to the footage when we had converted it to the correct color space, the key wouldn't work. So it was easier to just load the sequence of a matte from the previous key and then using that to set it to the alpha channel. Now let's see if I have that somewhere. So if I go into my main directory and then cleaned 7.1c, linear HD, linear, okay. So here is a matte sequence. Open that image, set it to image sequence, Control left click and then see if there's something to see. Okay, so this is a PNG sequence. This is the alpha channel of the previous key, which is then resized to the correct dimensions. And then here we have the footage, and he's using this keying node just for despilling, because the despill of the new keying node is quite good. So all he's doing here is despilling that. So all the green will be changed to a neutral color. And if you then set the alpha channel of that matte and pre-multiply that, then you will have the finished key. So this is a bit unfortunate because the file is really broken, so you cannot use that key down here. But at least maybe you can have a look at how he did stuff. And the masks are of course all still there. So maybe they should be here. So these are all the garbage mattes. So this is all used to get rid of all the stuff in the background. Then there are more masks here, so that was really insane. And then of course the main file. There is a layout file which we started to do at first, but later also quit doing that. So in the first weeks we were creating a track file, a mask file and a layout file, and then from the layout file we would generate the final file, but at some point we stopped doing that, so there was just a track, mask and the main file. In this case that is 7.1c. Often there would be an animation file so that Jeremy could do the animation on a lightweight file that is also using just the proxy robots and also just the low-res version of the footage without all the compositing crap. So that was the animation file, as you can see here. So we have lots of them, and it's very easy and fast to playback. Even in camera mode it should be reasonably fast. So that is the animation for this one robot. There are several layers with several robots, so that's very nice to playback. But let's have a look at the main file. I hope that all my links are working. It looks quite promising already. So first, let's see. So there are the arm guns, and the arm guns should use, they are using armatures. And let me see. So Okay, they are parented to a helper object. So if I shift G and then select the parent, there is this object, this proxy or helper object. Apparently it's using constraints to be parented to yet another helper object, which is the track object. So let's see. There is the outliner, and if I then search for TRK, not in the groups, but in the main scene. Okay, so there is the track for the arm gun. Aha, there we go. So this is the tracked object, and that way it's possible to animate the arm guns to maybe control some tracking issues. Also to correct the orientation, because as you can see here, the track is kind of inverted, and fixing that, I think that's the reason why I was using these helper objects. So the arm gun here is using constraints, and the rotation of the y-axis and the x-axis is inverted, and that way I think I could fix the flipping problem of the object track. And then of course the parenting of the armature to animate the arm guns. Then these circles, that's for the holdout material, because if you look from here, if I hide that, you can see this part of the arm gun, but of course not the composite. This has to be hidden. So with these objects, you could sort of create a hole in that part of the arm gun by using a cycles holdout material. So that holdout material works, I think, similar to a Z-mask. So that way you can cut out stuff from objects. Okay, so next there is all the stuff. I mean, of course, the robots and the background, and all have their render layers. So a render layer for the gun, for the foreground, for the quadbots, for masking objects for the quadbots, and lots of stuff. It's too much to show in this video. But what I can show you is to show you some effects, because the arm guns are using particle systems. We were calling them potato guns. So these are these effects that are simulated by using particle systems, and they are hitting objects in the background. So these are proxy objects for the robots, and are just used so that the particle systems could hit something, and then also to create smoke and all these effects. Then there is always some haze. So these were just objects to create with a material override, some kind of haze and mist pass. And unfortunately, I cannot show you the composite, or at least the result, because it takes too long to render for me. So that's that. Then scene is apparently empty. Okay, so main file, but at least we can have a look at the composite setup, even though I cannot show you the results. So this is the composite. Insane, totally insane, and Kjartan did a great job in doing that, and you can see Blender even crashed. Okay, so that was too much for my computer. So for this file you really need the Xeon Tesla workstations with lots of RAM. So do another try, maybe turn off use nodes so that it doesn't even try to render. So okay, there's probably some background stuff happening here. Then there will be the haze layers. Oh god, my god, this is insane. Okay, footage is coming in slowly. I mean, if you dare to do that, then go ahead and render and take a look at the composite. But I cannot do more than just demonstrate you this insane setup here. But the only way that you could do the smoke and effects was to use Blender internal with different Blender scenes. My god. Yeah, that's 7.1c. And 7.1g looks basically the same, more or less, but it's just using less effects. So 7.1g, I can quickly show you, there isn't even a mask file or a track file, because as I've told you before, it's using the same footage. So keying and tracking that was sort of one thing, and then we just imported that to a different file. So, okay, Blender crashes. Okay, 7.1G basically is the same scene, but the scientists are just waiting for the robots to come in, so we didn't have to render the robots or the effects. By the way, there was also, during the process, Rob was still working on the church file, so that's why this robot can magically go through this object here. So there are quite some intersections that shouldn't really happen, but that was too complicated to fix in the end. So that's 7.1c.